Hi, this video is part of a series of misconception videos on the topic factors and multiples. Factors and multiples are first introduced to the students in grade 4th. However, by using ACID data, we were able to notice that even students of grade 6th remain confused between the two ideas and often develop numerous misconceptions regarding both factors and multiples. Let us take a look at some examples. As you can see, the question here is testing the student's understanding of factors and multiples. Let's read the question. Shubhra thinks of a number. She says, 75 is a multiple of my number and 15 is a factor. Which of these numbers is definitely another multiple of Shubhra's number? Option A, 20, option B, 25, option C, 100, and option D, 300. The question is asking the students to identify another multiple of Shubhra's number. Now we know that one multiple is 75. Therefore, we can deduce that for another number to definitely be a multiple of Shubhra's number, it has to be a multiple of 75 itself. Hence, the correct answer is 300. However, only 25% of students were able to answer this question correctly. Over 46% of grade 6th students are marking 25 as the correct answer. Instead of finding a multiple of 75, they end up looking for the factor of 75. In this graph, I have total score on the x-axis and percentage of students marking the option on the y-axis. The maximum possible score, as you can see, is 40 marks. Here, we can clearly see that the misconception is most prominent in those students who are getting marks in the 10 to 20 bracket. However, even higher ability students who are scoring more than 20 on the test persistently have this misconception. Now let's look at another question. This is another ACID question that assesses the student's understanding of factors and multiples. The question reads, 13 into 3 into 11 is 429. Which of the following statements is true? Option A, 11 is a factor of 13. Option B, 33 is a factor of 429. Option C, 13 is a multiple of 429. Option D, 39 is a multiple of 429. The question is asking the students to identify the correct statement. Now we know that B is correct because 33 is a factor of 429. However, an alarming number of students have marked a smaller number like 13 and 39 as a multiple of the larger number 429. This clearly tells us that the students lack even a basic understanding of factors and multiples. Here, both option C and D are helping us catch this misconception. Now that we have established the misconception, let's look at one way in which we could resolve the same. It would help students if the definition of factors and multiples was arrived at by using some real-life examples and activities or visualizations. The question reads, Meera has 18 beads and she wants to divide them equally into groups to make necklaces. How many different types of groups can she divide them into? We know that the total number of beads are 18. The first group will have one necklace with all 18 beads. The second group will have 2 necklaces with 9 beads each. The third group will have 3 necklaces with 6 beads each. The fourth group will have 6 necklaces with 3 beads each. The fifth group will have 9 necklaces with 2 beads each. The sixth group will have 18 necklaces with 1 bead in each. Therefore, to divide the beads into groups, Meera uses factorization. Therefore, factors of 18 are 1, 2, 3, 6, 9, and 18. Now, if you introduce the student to the definition of factor, he or she would understand it in a much better manner. A factor of a number is an exact divisor of that number. Here, in the two cases, we see that 12 acts as a factor of 24 in the first and that it is also a multiple of 3 and 4 in the second. Therefore, a factor for a number can be the multiple of another number. Thank you. We hope this video enables you to learn with understanding.